Hello students, welcome to our online lecture for physics for 11th. There is your third chapter, that is motion in a plane. In this chapter, today we will discuss about the new point, that is the uniform circular motion, and under that uniform circular motion we will discuss about the tangential velocity, then about the centripetal acceleration, then we will introduce to centripetal force, then the period, radius vector, and at the last we will discuss about the angular speed. So at first we will focus on uniform circular motion. For that we will discuss about first the circular motion. You know there are the different types of motion. In the previous lecture we have been discussed about the rectilinear motion. The rectilinear motion means motion in a straight line. We know that there is the vibratory motion to and fro motion, that is the vibratory motion. When the body rotates about its axis, that is called as rotational motion. Like that, there is the circular motion. In circular motion, the path is circular. When the object is moving along the circular path, that motion is called as circular motion. And in the circular motion, when the object is moving along the path, at every point the direction of velocity changes. See here, in the circular motion we know about the motion, yes, and when the object is in motion it has some velocity. When the object is moving, here the object is along the circular path, at every point the direction of velocity is along the tangent to that circular path. Suppose your object is here, then this is the direction of velocity. If the object is here, this is the direction of velocity. Yes, at every point when the object is moving in a circular path, see in this direction, at every point the velocity is along the tangents, and that's why that is called as the tangential velocity. So when this tangential velocity has the magnitude as well as direction. Here the direction is along the tangent. When we consider only magnitude of that velocity, then it is called as speed. Means we can call it as linear speed, and that is the tangential velocity. When the object is moving, if the magnitude of this velocity remains constant, is that the direction we can't put constant, because every time the object has moved in a circular path, so direction of velocity go on changing. But every time when the direction of velocity go on changing, means that we can say if its magnitude is constant, yes, then we can call it as the speed. When the magnitude, now when the object is moving along a circular path with constant linear speed, though the direction is changing, direction is always along the tangent, is that, but its magnitude, means magnitude of vector v is constant, then it is called as speed. When we take only the magnitude, we call it as speed. If the speed is constant and the object is moving along a circular path with constant speed, then it is called as uniform circular motion. For that, I will show you here object. Suppose this is a circular path, circular track, and when the object is moving along the circular path, see here, when the object is moving, at every point the direction of velocity changes, and that's why the object can move. Is that when there is the change in direction of velocity, there is the acceleration, and this acceleration is along the direction of velocity actually. But in linear motion, when the object is change its speed, increase its speed, we call it as accelerate. Is that आपण acceleration use करतो कार मध्ये, accelerate झाला, acceleration. Is that in that case when the velocity increases, the acceleration is in the direction of velocity. When the velocity decrease, yes, means deceleration, speed decrease करतोस, brake लावतोय, in that case the velocity decrease, the acceleration is opposite to the direction of velocity, and in the direction of acceleration there is a resultant physical quantity, that is the force. So this is about the motion. In every motion there is, when there is a change in velocity, we call it as acceleration. आपल्या मागच्या व्हिडिओमध्ये आपण velocity, acceleration हे सगळं डिस्कस केलेलं आहे. Is that so? Velocity change, then there is the acceleration. Here, what is the important thing here? When the object is moving along a circular path, if the direction of acceleration is along the direction of velocity, समजते ना? म्हणजे बघा, ऑब्जेक्ट इथे आहे, डायरेक्शन ऑफ व्हेलॉसिटी दिस कॅप रिप्रेझेंट अलॉंग द टँजेंट. ॲक्सलरेशन जर याच डायरेक्शन असेल तर ऑब्जेक्ट या डायरेक्शनने मूव्ह होईल, स्किड होईल along its circular path. It cannot maintain its circular path. So to maintain the circular motion, the object must have some acceleration. That acceleration is perpendicular to that object, and that is called at here the centripetal acceleration. We will discuss each and everything in detail. Actually, uniform circular motion in your 11th syllabus, uniform circular motion, there is only introduction, and in your 12th there is the first chapter, that is the rotational dynamics. There again the uniform circular motion, non-uniform circular motion is given in detail. You have to study there in detail the circular motion. If you want to do the detailed study of uniform circular motion, you can observe my first 3 or 4 videos for the chapter 12 that are for rotational dynamics on the same channel, that is Easy Physics by V.S. Malle. I will send you the link for that also. So what is here about the circular motion is that the circular motion we called as when the object is moving along a circular path, that motion is called as circular motion. And if that object moving along a circular path with constant speed, then it is called as uniform circular motion. Now in the uniform circular motion, the velocity is called as tangential velocity, because at every point the direction of velocity is along the tangent. Then we discuss about the centripetal acceleration. See here, this is the center of the object, or here this is the center of the object. Though the magnitude of velocity is constant, but the direction is changes. Direction is along the tangent, and so it is called as the tangential velocity, and the speed is constant because the magnitude is constant. At every point there is the acceleration directed along the radius towards the center. That acceleration is called as here centripetal acceleration. For the centripetal, and this centripetal acceleration is necessary, it is must for the uniform circular motion. Without centripetal acceleration, the object cannot do the uniform circular motion. We can give the example, we can discuss about the example of motion of moon around the earth. It is approximately near about circular motion, and when the moon performs circular motion around the earth, the gravitational force of attraction between the earth and moon provide there the proper centripetal acceleration, and that's why the moon can perform the circular motion. So for that circular motion, this centripetal acceleration is necessary. Yes. In your 11th syllabus, you have to find the expression for centripetal acceleration. We will discuss it about in the next video. Then there is the centripetal force. When there is the centripetal acceleration, is that now here the centripetal acceleration that is directed along the radius towards the center. In the motion, when there is the change in velocity, velocity badalli, acceleration येतं. When there is the acceleration, according to Newton's second law, we know that force is equal to mass into acceleration. As the object has some mass and it is in motion, the acceleration arises there when there is the change in velocity. Then in the direction of acceleration, the force is acting on that object. Here also the acceleration is centripetal acceleration. That's why the force acting on that object is also called as centripetal force. In detail, you have to study it in 12th. You can see that videos for centripetal force and centrifugal force also for the 12th. Now about the period. We will discuss about the period, and then we will discuss about the radius vector. When the object is moving, see here, in the non-uniform circular motion, means in the circular motion, if the velocity is not constant, means speed is also not constant. Is that your car is moving along the circular track, suppose, is that if it is moving with the constant speed, बघा, जर स्पीड कॉन्स्टंट असेल, सपोज 50 किलोमीटर पर सेकंद व 50 किलोमीटरच्या स्पीडने कार जर मोशन करते आहे, समजते आहे, दॅट इज कॉल्ड ॲज युनिफॉर्म सर्क्युलर मोशन. स्पीड कॉन्स्टंट आहे आणि स्पीड जर वाढवला 50 देन 70 100 अगेन 50 है ना, स्पीड आपण इन्क्रीज डिक्रीज केला, दॅट इज नॉट द uniform circular motion, that is the non-uniform circular motion. So what is period? When the object move along the circumference, yes, from the point, from any point, it start its motion. समजते सर्क्युलर ट्रॅकवर गोल फिरून ऑब्जेक्ट बघा पुन्हा इथेच येतो आहे. समजतंय? फॉर वन सर्क्युलर मोशन द टाइम टेकन बाय दॅट ऑब्जेक्ट फॉर वन सर्क्युलर मोशन दॅट इज कॉल्ड ॲज पिरियड ऑफ द ऑब्जेक्ट. इज दॅट? Yes. What is period? It is denoted by capital T. The time taken by that object to complete one revolution, that is called as the period of the object, and it is the assigned for period is second. Period is calculated in second. So for the period I will give you the example of when in the clock is that for the minute hand, when the minute hand perform uniform circular motion, because the minute hand move in a clock with constant speed, and to complete one revolution it takes the 60 minute. Is that so? That is its 60 minute is the period of that minute hand. For the hour hand, it perform one complete revolution in 12 hours. So we can call it as the period of that hour hand. For second hand also we can say 60 seconds. That is the period of the second hand. So when the object move in a circular motion, when it complete one revolution, the time taken by it to complete one revolution, that is called as the period of the object. Now we discuss about the radius vector. See, we use this diagram here. Radius vector. When the object is moving, when the object is at different position, to show the position of that object, we draw some vector from center to the point. The direction is towards the object. This vector is called as radius vector. Is that? Vector पण आपण मागच्या चॅप्टर मध्ये शिकलेलो आहे, स्केलर अँड वेक्टर. The physical quantity which have magnitude as well as direction, that is called as the vector. Here the magnitude means the radius of that circle gives us the magnitude, and the direction of object, when the object position of object gives us the direction at different position. Suppose your object is here, this radius vector give only the magnitude, and this arrow shows you the position of that object. So that is called as radius vector. Now we discuss about the angular speed. So before that we will see about the angular displacement. In your 11th syllabus, the angular displacement is not given, but to study the angular speed, we discuss about the angular displacement. Now you know about the linear displacement. आपल्या फर्स्ट व्हिडिओ मध्ये आपण पाथ लेंथ अँड डिस्प्लेसमेंट बद्दल डिस्कस केलं होतं. डिस्प्लेसमेंट मीन्स distance covered by that object in a particular direction, that is called as displacement. That is when the object is moving in a linear path. Suppose the path is linear, the object is moving in a particular direction. So this is called as the displacement, and that is the linear displacement. In the linear motion there is the linear displacement. In the circular motion, see here, in the circular motion, listen here carefully. When the track is circular, now this is the center. Suppose the object is at point A. It is shown by the radius vector. Now after some time, your object is moving to point B. It is at point B now. Again we draw the radius vector to show its position. Now see here, when the object move, it covers this linear distance. Yes. त्यांनी पूर्ण सर्कलचा एवढा पाथ म्हणजे एवढा रस्ता कव्हर केलेला आहे, दॅट इज द लिनियर डिस्टन्स. नाउ इन दॅट केस द रेडियस वेक्टर सी हियर ॲट द सेंटर टर्न बाय सम अँगल थीटा, दॅट इज कॉल्ड ॲज अँगुलर डिस्प्लेसमेंट. द अँगल ट्रेस बाय द रेडियस वेक्टर ॲट द सेंटर when the object is performing circular motion, that is called as angular displacement. When the object is here, बघा इथे ऑब्जेक्ट असेल आपण परफेक्टली म्हणू शकतो अँग्युलर डिस्प्लेसमेंट थीटा इज इक्वल टू पाय बाय 2 that is equal to 90 degree. When the object is here in the circular motion, we can say this angle pi radian, C position suppose, is that theta is equal to pi radian or 180 degree. When the object is here, बघा angular displacement एवढं राहील, that is theta is equal to 3 pi by 2, 270 degree. And when the object is here, when object complete one complete revolution and come against at the same point, we can say the angular displacement theta is equal to 2 pi radian. So when the angle traced by the radius vector at the center, that is called as angular displacement. This angular displacement changes with respect to time. As in the case of linear velocity, see here. Linear velocity म्हणजे काय? Rate of change of linear displacement, that is displacement upon time, is called as linear velocity. Similarly, the angular velocity is nothing but the angular displacement per unit time. That is called as angular velocity. Here we take only magnitude, so we call the angular speed. So in your 11th class it is given that the angular speed is denoted by the quantity omega. It is not called W, we call it as omega for the angular speed, and it is the rate of change of angular displacement. Means we can say angular displacement upon time, that is theta upon t. Angular displacement in the given time, that gives us the angular velocity, that is the rate of change of angular displacement is called as angular velocity. As theta is measured in radian and time is in second, the SI unit for angular velocity is radian per second. This is about the angular velocity. Now about the linear velocity. Now we discuss about the linear speed. As we know about the angular speed, see here, we know about the angular speed. So for the linear speed, that is the magnitude of linear velocity, it is called as the linear speed, and it is the distance upon time. We can calculate the speed as distance upon time. When we call it as velocity, velocity is the rate of change of displacement, and here we calculate only magnitude. Magnitude of velocity is called as speed. So here the linear speed is equal to distance upon time. So when the object, see here I draw again the diagram, when the object moving along the circumference of circle with constant linear speed, it is called as a uniform circular motion. This is point A, this is point B, suppose this is a radius vector. When the object moves from A to B, the radius vector turn by the angle theta, that is called as the angular displacement. So as r is the radius vector, here r is the radius of this circular track or circular path, we can say when the object moving along the circumference and complete one revolution, the distance covered is equal to circumference, that is 2 pi r. Is that? And when the object move along this circle and complete this distance 2 pi r, the time taken by it is called as period. It is denoted by capital T. So I can put here T. So for the linear speed, we can use this formula, circumference upon period or 2 pi r upon capital T. We can use this formula in the formula of angular speed. So see here about the angular speed. In the angular speed, we take omega, that is the angular displacement upon time. So for angular speed, we can find one formula, that is when we take the t, that is capital T period, in one period, एका पूर्ण पिरियड मध्ये एक रिव्होल्यूशन कंप्लीट होते. एक रिव्होल्यूशन कंप्लीट झालं तर ऑलरेडी टेल यू that angular displacement, that is 2 pi radian. So I can put here 2 pi. So omega is equal to twice pi upon t. This is the important formula for angular velocity. Yes, sorry, angular speed. Here we take angular speed is equal to twice pi upon t. Is that? Now we multiply and divide the numerator and denominator. So omega is equal to, I can say twice pi r upon t into r. So twice pi r upon t. So I get again formula omega is equal to v by r, or we can say v is equal to r omega. In 12th you have to study these all formulas in detail. Is that? So formula for angular speed, omega is equal to twice pi upon t, where t is the period. Formula for linear speed, that is twice pi r upon t, where t is the period. And there is one relation between the angular speed and linear speed for uniform circular motion, that is omega is equal to v by r, or v is equal to r omega. These all क्वांटिटी और ऑल डिस्कशन यू हैव टू लर्न इन 12th क्लास ऑल्सो. आपको अगर डिटेल में पढ़ना है तो रोटेशनल डायनेमिक्स चैप्टर में आपको 12th में सेम सभी पढ़ना है. यू कैन ऑब्जर्व द फर्स्ट 3 वीडियोस फॉर रोटेशनल डायनेमिक्स. थैंक यू.